Hi, this is a continuation of the first lecture on lines and angles. Today we'll look at a bunch of theorems and some results corresponding to triangles. Stating theorem number 2, if a transversal intersects two parallel lines, then each pair of alternate interior angles is equal. Basically, this statement says if these two are parallel lines and this is the transversal in question, angle 4 is equal to angle 6 and angle 3 is equal to angle 5. Let's see how we go about proving this. Considering a transversal is a straight line, this would correspond to a ray and therefore angle 1 and angle 4 form a linear pair of angles. And so therefore angle 1 plus angle 4 is equal to 180 degrees. Also, look at angles 5 and 6. They also form a linear pair of angles. So therefore angle 5 plus angle 6 is equal to 180 degrees. Now recall our earlier axiom on corresponding angles, which stated that angle 1 is equal to angle 5. Now replacing angle 5 by angle 1 in this statement, we get angle 1 plus angle 6 is equal to 180 degrees. Now on subtracting this statement from this statement, we get angle 4 minus angle 6 is equal to 0. You can verify that by doing it yourself and you get angle 4 is equal to angle 6. And that is what we had started off to prove. We can use the same property and the same line of reasoning to prove that angle 3 is equal to angle 5. That is being left out as an exercise. Next theorem states, if a transversal intersects two lines such that a pair of alternate interior angles is equal, then the two lines are parallel. Basically, this is the converse of theorem number 2. Theorem number 4. If a transversal intersects two parallel lines, then each pair of interior angles on the same side of the transversal is supplementary. Basically, this says angle 4 plus angle 5 because these are interior angles on the same side of the transversal. The theorem states that these two are supplementary. That is, angle 4 plus angle 5 is equal to 180 degrees. How can we prove that? We can prove that with the equality of angle 4 and angle 6, which we did in theorem number 2, and we can use that in this way, because angle 5 plus angle 6 is equal to 180 degrees because they are a linear pair of angles, and angle 6 is equal to angle 4. We get angle 4 plus angle 5 is equal to 180 degrees. So we have proved angle 4 in a very crude fashion. You can work out the formal way of writing. That is also being left out as an exercise. But this is basically the crux of the argument. And let's look at theorem number 5, which is if a transversal intersects two lines such that a pair of interior angles on the same side of the transversal is supplementary, then the two lines are parallel. Again, theorem number 5 is the converse of theorem number 4. Theorem number 6. Lines which are parallel to the same line are parallel to each other. Theorem number 7. The sum of the angles of a triangle is 180 degrees. Let's look at the proof of this theorem. Say we have a triangle A, B, C. Let's call this angle 1, angle 2, angle 3. And now let's draw a line passing through point A and parallel to line segment BC. Let's say this is the line in question. And let's call this angle number, say, 4 and angle number 5. Right? Now, and this is, say, line L. Now L is parallel to BC. Right? And now from earlier theorems, we know that alternate angles are equal. So therefore angle 5 is equal to angle 3, and also angle 4 is equal to angle 1. We also know that because angle 4, angle 2 and angle 5 lie on a straight line, we have angle 4 plus angle 2 plus angle 5 is equal to 180 degrees. And replace angle 4 by angle 1 and angle 5 by angle 3, we have angle 1 plus angle 2 plus angle 3 is equal to 180 degrees. This goes on to prove theorem number 7, that is the sum of the angles of a triangle is 180 degrees. If a side of a triangle is produced, then the exterior angle so formed is equal to the sum of the interior two interior opposite angles. That is, say if this were a triangle and this were the produced side, and say this was angle number 1, this was angle 2, and this is angle 3, and this is angle 4. This theorem states angle 4 is equal to angle 1 plus angle 2. Let's see how we can prove this. We know that angle 1 plus angle 2 plus angle 3 is equal to 180 degrees from theorem number 7. Also note that angle 3 and angle 4 are linear pair of angles, so therefore angle 4 plus angle 3 is equal to 180 degrees. Now subtracting this statement from this statement, we have angle 1 plus angle 2 minus angle 4 is equal to 0. This implies angle 4 is equal to angle 3 plus, angle 2 plus angle 1, which is what we had started off to prove. Now finally let's look at a question which will basically put to use all the theorems and axioms we have learnt in this chapter, in this lecture, or at least some of them. The objective of this question is to find y and x. Now let's look at how we can proceed with this question. First thing we notice is that angle QTR is a right angle triangle. Angle QTR is right angled triangle. This implies angle QTR is equal to 90 degrees, and also we know that angle TQR is equal to 40 degrees according to the question. So therefore, by the property that the sum of the angles of a triangle is 120 degrees, we have x plus angle QTR plus angle TQR is equal to 180 degrees. This implies x plus 90 degrees plus 40 degrees is equal to 180 degrees. This implies x is equal to 180 minus 90 minus 40 is equal to 50 degrees. X is equal to 50 degrees. Now let's look at, let's just state it here, x equal to 50 degrees. Now let's look at how we can find out the value of angle y. One way to go about it would be to say, looking to look at triangle PSR and consider RS extended to Q and y to be the external angle of triangle PRS. And so therefore, by an earlier theorem, we have y is equal to angle PRS plus angle SPR. This implies y is equal to 30 degrees plus x is equal to 30 plus 50 is equal to 80 degrees. And so therefore we have found out the value of y also. So you see how the application of the theorems and axioms we learned in this chapter can be put to use to find angles, say in this question, and this can be done so for other questions that you may face. This is all that there is to lines and angles. Thank you very much.